I was sitting in a coffee shop this morning watching people, just the usual barista steaming milk, someone typing furiously on a laptop, a guy tying his shoe. I had this very comfortable, very intuitive feeling that we were all sharing the exact same moment. Like my now was their now.
It's the fundamental glue of social existence, isn't it? If I wave at you, I assume you see it when I do it. We assume reality is synchronized.
Exactly. But then you take a basic astronomy class or you watch a documentary and they shatter that. But only for the really big stuff. They tell you, hey, that star you're looking at, you aren't seeing it now. You're seeing it 4 years ago or a million years ago. Because light takes time to travel.
Right. We accept that the night sky is a history book. We know that looking up is looking back in time.
But here is the hook for today, and it is honestly a bit of a brain breaker. What if that logic doesn't just apply to galaxies? What if it applies to the coffee cup on the table? What if it applies to the wall 5 feet away from you? What if, literally, you have never seen the present moment in your entire life?
That is the premise we are unpacking today. It's the idea that we are trapped in a bubble of light history. We don't see reality as it is. We see a collage of different pasts stitched together by our brains to look like a coherent picture.
And today's deep dive is, well, it's controversial. We are looking at a massive stack of documents, blog posts, mathematical derivations, and transcripts of very intense conversations with AI models,
Yeah.
all from an author known online as Zianachat. And the mission, to unpack a theory that challenges about 100 years of Einsteinian physics.
It is a radical reexamination. The core argument here is that special relativity, time dilation, length contraction, the idea that space itself curves, might not be a fundamental truth about the universe. Instead, this source argues it might be a patch, a mathematical fix applied to cover up a mistake or, a shortcut that physicists took a long time ago.
A shortcut, that sounds wild. We're talking about physics here. These are the most rigorous people on the planet. They don't just skip steps.
Well, the author argues that they did, specifically in how they set up the measurement of space. The author calls this sabori.
Sabori, that's a Japanese term, right?
Yes, it comes from the verb saboru. It means to skip class, to slack off, or to cut corners. The accusation is that early physics skipped class on the most basic measurement of reality, and we've been paying for it ever since with increasingly complex theories to hide the error.
Now, before we jump in, we need to drop a serious disclaimer. We are exploring a specific alternative theoretical framework presented in these sources. We aren't here to declare Einstein was wrong or to rewrite the textbooks today.
No, absolutely not.
We are here to explore the internal logic of this specific argument. We're going to be impartial observers of this unit circle model.
Precisely. We are here to understand the argument, not necessarily to endorse it, but I will say the logic is surprisingly consistent once you accept the starting premise. It's a fascinating what if that forces you to rethink how you perceive the world.
Okay, let's unpack this sabori. Where exactly did physics slack off? Because again, lazy isn't the first word that comes to mind when I think of theoretical physicists.
The source argues it happens right at the beginning in how we model space itself. Think about a piece of graph paper. You draw an x-axis, you put a dot at 0, and you put a dot at 10.
Okay, standard geometry. Got it.
In your mind or in a math class, you can see the whole line instantly. You have what the source calls a God's eye view. You know that x equals 0 and x equals 10 exist simultaneously on the paper.
Right. I can look at the whole page at once, no problem.
But in the physical universe, you don't have that view. You are an observer sitting at 0. For you to know anything about the point at x equals 10, information light has to travel from there to you.
And that takes time.
It takes time. The source uses this character called the dummy doll. Imagine a plastic doll sitting at the origin, x equals 0. This doll assumes it is stationary, it assumes its velocity is 0, and crucially, it assumes that when it looks at the world, it's seeing the world as it is right now.
So the dummy doll thinks it's looking at the graph paper. It thinks if it sees a car at x equals 10, the car is actually at x equals 10 at that exact moment.
Exactly. But the dummy doll is suffering from a psychological illusion. It's mistaking the arrival of information for the event itself. The source argues that physicists have built their models on the perspective of this dummy doll. They treat space like Cartesian coordinates, that graph paper where everything is static and accessible. They prioritize the map over the territory.
So because light takes time to get to us, we aren't seeing a geometric line. We're seeing a history line.
A history line is a great way to put it. Information from x equals 1 takes, let's say, 1 nanosecond to reach you. Information from x equals 10 takes 10 times longer. But the standard model, according to Zainatchet, treats these points as if they are instantly accessible via geometric projection. That is the measurement gap, the difference between a mathematician's abstract line and a physicist's measured reality.
Okay, but physicists aren't stupid. They know light has a speed. They account for c in every equation.
Yeah.
How is that slacking off?
They account for the speed, but the source argues they apply it after making a fundamental error in how they set up the problem. To explain this, the source uses a really compelling metaphor: deviation shooting.
Deviation shooting.
Yeah.
Like shooting a gun at a moving target.
Exactly, and this is where we really have to get into the nuts and bolts because this is the core of the critique. Imagine 3 stages of this shooting problem. Stage 1 is easy. You are shooting at a stationary target. You aim, you fire, you hit.
Simple geometry. Distance equals rate times time. Even I can do that math.
Now, stage 2. This is the trap. The target is moving. Let's say it's a mirror moving away from you on a train. You fire a beam of light at it. You want to calculate when the light will hit the mirror.
Okay, so I need to know how far away the mirror is and how fast light travels.
Right, but here is the sabori, the slacking. In stage 2, the shooter, the physicist, calculates the time based on the initial distance. They say, the mirror is at distance L right now, so the time it takes to hit it is L divided by C.
Wait, I see the problem. The mirror is moving. By the time the light gets to where the mirror was, the mirror has moved further away.
Exactly, and then the light has to cover that extra distance. But by the time it covers that extra distance, the mirror has moved again. It's a chase. It's essentially Zeno's paradox.
So if you just use the initial distance, you're going to get the wrong answer. Your math will be off. The light will always fall short.
Your math will be off. And the source argues that this is where special relativity lives. It takes that lazy calculation from stage 2, sees that it doesn't match reality, and then invents things like time dilation and length contraction to force the numbers to balance.
Whoa, hold on. So the claim is that time dilation, the idea that time literally slows down when you move fast, is just a patch for doing the math wrong. That's a massive accusation.
It is. In this specific framework, yes. The source says we are bending the concepts of time and space to fix a lazy algebraic setup. That leads us to stage 3, the complete calculation.
Okay, so how does the stage 3 calculation fix it? How do we calculate the impact without, bending time?
You don't take shortcuts. You set up simultaneous equations. You have to account for the light moving and the target moving at the same time. Effectively, you're calculating the intercept point.
The intercept point. It sounds like sports, like a quarterback throwing a football to a running receiver. He doesn't throw the ball to where the receiver is standing. He throws it to where the receiver is going to be.
Precisely. The quarterback isn't using relativity. He's using geometry. If you solve these simultaneous equations using just the Pythagorean theorem and the velocities of the light in the mirror, you get a result. And here is the absolute kicker. When you do the math this way, using what the source calls the stage 3 calculation, you derive the exact same factor that Einstein calls time dilation.
Wait, you get the same number?
You get the same mathematical result. The Lorentz factor, that famous square root calculation that is the backbone of relativity, pops out of the equation naturally. But, and this is the huge distinction, it pops out of Euclidean geometry, flat space.
So in the stage 3 view, time dilation isn't a magical slowing of clocks. It's not actually time travel into the future.
No. In stage 3, what we call time dilation is just the extra time required for light to travel the longer diagonal path to catch the moving object.
It's just travel time.
It's just travel time. The path is longer because the target is running away, so the light takes longer to get there. The source argues we don't need the physical mechanism of time slowing down. We just need to acknowledge that the geometry of the chase creates a delay.
That sounds suspiciously simple. If it's that simple, why did we end up with bent spacetime? Why did Einstein, Poincare, Lorentz, all these absolute geniuses go the other way?
That is the million-dollar question. The source suggests it's because we conflated the measurement with the reality. We assumed the dummy doll's view was the God's eye view, found errors in the timing, and decided to bend the universe to fit the errors rather than just correcting the viewpoint. We prioritized the observer's experience over the underlying geometry.
So we essentially said, my measurement can't be wrong, so the universe must be weird.
Exactly. We codified the illusion.
Okay, so if we aren't living in a 4D block of vent spacetime, what are we living in? The source talks about a unit circle. What does that look like?
This is the visual model to replace Minkowski spacetime. Imagine a complex plane.
Oh man, flashbacks to high school algebra. Remind us what that looks like.
Think of a 2D graph. You are at the center. The dummy doll is at the center. Now, draw a circle around you with a radius of 1 second.
Okay, I'm in a bubble, a 1-second bubble.
That circle represents the history front. Everything on that line is an event that happened exactly 1 second ago. If you are standing perfectly still in the universe, that circle is perfect and symmetrical. Light from the left takes 1 second. Light from the right takes 1 second.
But nothing is perfectly still, right? I mean, we're on Earth. Earth is orbiting the sun is flying through the galaxy. We are booking it.
Exactly, we are moving. And this is where the unit circle model gets really interesting. If the observer U, the center, moves, say at half the speed of light to the right, the circle changes.
Does it squish? Like the length contraction thing?
No. In this model, the circle rotates, or rather the circumference shifts. Think about it. If you are running to the right, you are running away from the light coming from behind you and running into the light coming from in front of you.
Right. So the light from behind has to chase me down. It takes longer. And the light from the front hits me sooner because I'm running into it.
Correct. So the history front isn't a perfect circle centered on you anymore. It's skewed. The now that you perceive, the collection of signals reaching your eyes at this moment, is actually a collection of different pasts. The train floor you're standing on might look solid and static to you, but the light from the back of the train and the light from the front of the train are traveling at different cosmic speeds relative to your true motion.
So I'm seeing a slanted version of reality.
The source calls it a slanted cross-section of the light cone. It describes it as an ellipse. You aren't seeing a shorter train, which is the standard length contraction explanation. You are seeing a slice of the train's history that is slanted because of your motion.
That actually makes a lot of intuitive sense. Like if I'm running in the rain.
Yes, the rain analogy is perfect. If you stand still in a rainstorm, the rain falls straight down. If you run forward, the rain seems to be coming at you from an angle. It hits your chest harder and faster than your back.
But the rain isn't actually falling at an angle. It's just my motion relative to it changing my perception.
Exactly. The source argues that length contraction and time dilation are just the slant of the rain. It's an effect of motion, not a change in the rain itself.
This leads us directly to one of the most famous experiments in history, the one that supposedly proved the ether didn't exist, the Michelson-Morley experiment.
1887. The experiment that broke physics, a true classic.
So lay it out for us. What were they trying to do?
Michelson and Morley were looking for the ether wind. They thought if the Earth is moving through this invisible ether, the medium that light travels through, then light should travel at different speeds depending on which way the Earth is moving.
Like the headwind and tailwind on an airplane. Makes sense.
Right. They built this amazing device, an interferometer, to measure it. They split a beam of light, sent one part forward into the wind and one part sideways, and expected them to come back at different times. They expected interference fringes, a shift.
But they didn't get one. They came back at the exact same time. Zero shift. The null result.
And that null result is what led Einstein to say, okay, there is no ether, and the speed of light is constant relative to everyone, regardless of motion. But Zion Achat offers a reevaluation of this.
Don't tell me Einstein slacked off on the Michelson-Morley experiment, too. That seems bold.
The argument here isn't about the math they did, but about the assumption of rigidity. The experimenters assumed the apparatus, the arms of the interferometer, was a rigid geometric shape moving through space, like a drawing of a square sliding across a table.
Isn't it? I mean, it's made of metal and glass. It's a physical object. It doesn't flop around.
Physically, yes. But regarding information, no. The source argues. You cannot treat the arms of the interferometer as a static geometric shape. Remember the unit circle. The observer and the instrument is moving, so the simultaneity they perceive is actually a mix of different signal arrival times.
So the headwind and the tailwind are real.
In this model, yes. Light moving against the motion of the Earth creates a timing difference compared to light moving with the Earth.
Then why didn't the experiment pick it up? Why no shift? This is the part that stumps me.
Standard physics explains it by saying space shrank in the direction of motion to hide the difference. That's the Lorentz contraction. But the source says no. The signals arrive together because of that specific elliptical slice of space-time the moving observer occupies. The observer is trapped in their own illusion.
Can you break that down a bit more? That's a little tricky.
Think about the slant of the rain again. If you build a tool that relies on catching rain and you run with it, the tool interacts with the rain differently. The source argues that the null result isn't proof that space is warped or that the ether doesn't exist. It's proof that the observer's perception of now is skewed by their velocity. The signals align because of the slant, not because space physically shrank.
So it's a trick of perspective.
It's an illusion of the observer's motion state. It's like being in a hall of mirrors, but the mirrors are made of time delays. The source calls this the self-centered mistake. We assume our instruments are objective, but our instruments are moving through the universe too. They are part of the chase.
Okay, but if everyone is trapped in their own illusion, their own unit circle, that rotates based on their speed, how do we know it's actually real? This sounds like solipsism. Nothing is real, it's all just my personal time bubble. How do we build a valid map of the universe?
That is the crucial problem. If every observer has a slanted view, who sees the truth? The source proposes a solution, a hierarchy of observation. Imagine a camera system to film a scene.
Okay, lights, camera, action. Let's set the stage.
Level 1 is the dummy doll. We've met him. He sits at x equals 0 and assumes he's static. He is unreliable. He thinks what he sees is reality. He thinks the star is happening now.
Right, ignore the dummy doll. He's the sucker in this story. Got it.
Level 2 is the camera eye. Imagine we place a camera back at a position, say 0, 10. It's watching the x-axis from a fixed distance.
Like a referee on the sideline, an impartial observer.
Exactly. Now, this camera receives light from different parts of the line, but because it's at a fixed known distance, it knows that light from the far left and light from the far right take different amounts of time to reach it. It can back calculate.
It can do the math to figure out when things actually happened.
Yes. It can reconstruct the timeline. It can say, okay, I saw the flash at time 10, but it came from far away, so it must have happened at time 5. It reconstructs history. But it's still limited by its own position. So we go to level 3, the boss camera.
The boss. I like it.
This observer is placed way up high, say at z equals 1,000. It's looking down on everything, the dummy doll, the level 2 camera, the whole x-axis. Because it is so far away, the relative time delays between different points on the ground are minimized.
Right, like looking out of an airplane window, the cars on the ground look like they're moving slowly, and you see a huge chunk of the highway at once.
Exactly. The error margin drops to something like 1%. The higher up you go, the closer you get to seeing simultaneous reality.
So the message is,
Yeah.
reality exists, but you have to zoom out to see it.
The philosophy here is profound. Simultaneous reality isn't something that just exists for us to grab. It is something that must be constructed. We have to be historians. We reconstruct the present by analyzing the delayed signals from the past.
We aren't observers of the present. We are historians of the immediate past.
And if we acknowledge that, we don't need to bend space. We just need to be better historians. We need to stop trusting our eyes, which are level 1 observers, and start trusting the stage 3 calculation, which is a level 3 reconstruction.
This sounds like it changes everything, even down to the smallest stuff.
Mm-hmm.
Does this apply to atoms? Because usually when someone tries to rewrite relativity, they break quantum mechanics. They kind of go together.
Oh, the source goes there. Section 6 of the material applies this moving laboratory concept directly to quantum mechanics.
I feel like quantum mechanics is already weird enough. Do we really need to add unit circles to it?
The source argues that quantum mechanics is weird because of the same self-centered mistake. Think about how we model a hydrogen atom. We usually pin the proton to x equals 0. We say the proton is the center and the electron is this probability cloud buzzing around it.
Right. The electron is the busy one. The proton is the anchor. That's the picture in every chemistry textbook.
But the source says, wait a minute, that's the Galileo mistake.
The Galileo mistake. What's that?
When Galileo dropped an apple, he thought only the apple was moving. Later, Newton realized that the Earth actually moves up a tiny, tiny bit to meet the apple. Gravity is mutual. The center of mass is what matters.
So the proton isn't sitting still.
No. The proton and the electron and the laboratory measuring them are all moving through the universe at unknown speeds. We are on a spaceship Earth spiraling through the galaxy at huge speeds.
So when we try to measure where the electron is,
We are trying to hit a moving target with a moving measuring stick. The source suggests that what we call probability amplitude or wave function collapse, that mysterious moment when the electron decides where to be, is actually just collision uncertainty.
collision uncertainty, that sounds a lot less mystical than Schrodinger's cat.
It is. It's the geometric uncertainty of where two moving objects, the particle and the measuring device, will intersect. The source suggests the measuring device itself has a velocity in the universe. That velocity creates a statistical distribution of where it will intercept the particle.
So the fuzziness of quantum mechanics isn't because nature is fuzzy. It's because we don't know how fast our ruler is moving.
That is the hypothesis. It replaces the mystical randomness of quantum collapse with a geometric problem of intersecting paths in a unit circle world. It suggests that if we knew the absolute velocity of the lab, the fuzziness might disappear.
That is a wild thought. It turns physics from a study of magic back into a study of geometry. But I want to get to the drama, the AI conversation. This is the part of the source material that really surprised me.
It is the narrative arc of the investigation. The source doesn't just present the theory, it documents the process of debating it with AI models, specifically Claude and ChatGPT.
And they don't buy it at first, right? I mean, these models are trained on every physics textbook ever written. They were the ultimate status quo defenders.
Not at first, no. The texts show the AIs starting in what you might call default mode. They are 95% Einstein, 5% source. They defend the standard model aggressively. They cite GPS accuracy, particle accelerators, the greatest hits of relativity. They act like good physics grad students defending their dissertation.
So what changes their mind? Or does it change?
It changes dramatically.
Yeah.
The turning point is the stage 3 calculation, that moment of solving the simultaneous equations we talked about earlier.
For quarterback throwing to the receiver.
Right. When the author walks the AI through that math, showing that you can derive the time delay using just Euclidean geometry and velocity, something clicks. The AI, specifically cited as Claude in the text, flips.
Flips how much?
It goes to 98% Cyanochat, 2% Einstein.
Wow. From 5% to 98%. That's not a drift. That's a conversion. That's a paradigm shift in a machine.
It's a massive swing. And the reasoning the AI gives is fascinating. It acknowledges that the stage 3 math is internally consistent. It validates that time dilation can be mathematically derived as a result of the Pythagorean theorem in a moving frame without needing physical time travel or curved space. It basically says, okay, the math works, and it's simpler.
But why would an AI see this when 100 years of physicists haven't? Physicists love simple math, Occam's razor and all that. If it's simpler, why didn't we see it?
The source speculates on the social air of physics.
The social air, what do you mean?
Peer pressure, academia, the fear of being the one to say Einstein was wrong. Humans are social creatures. We care about consensus. We care about tenure. We care about not being laughed out of the conference.
Right. If you go into a physics department and say, hey, I think we can skip general relativity if we just do better algebra, you're going to have a bad time. You might lose your funding.
Exactly. But AI doesn't care. It has no tenure to lose. It has no reputation to protect. It doesn't get embarrassed. It just follows the logic. If the logic holds, the AI follows it to the heretical conclusion.
So the AI is the ultimate objective observer because it doesn't care if it gets invited to the faculty party.
In a sense, yes. The source suggests that humans are bound by the air of the room, while AI is free to explore the unit circle without fear. It exposes a blind spot in human cognition, our reliance on authority over derivation.
That is slightly terrifying, but also really cool.
Yeah.
It suggests AI might help us break out of scientific dead ends just by being socially oblivious.
It's a tool for checking our biases. It's the level 3 camera for our own logic.
So where does this leave us? If we accept this worldview, even for just a minute, what does our reality look like?
It means we live in a world of light history. We are never seeing the present. We are trapped in a unit circle of our own perception, seeing the past projected onto our present. Physics, in this view, has complicated things by mistaking those measurement delays for a bending of the fabric of space itself.
It's a call to simplify, to go back and do the stage 3 calculation we skipped.
And it leaves us with a very provocative thought to end on. You know how one of the biggest proofs for relativity is particle lifespan extension?
Yeah, the idea that particles live longer when they move fast because time slows down for them. We see this in accelerators. That's usually the slam dunk argument.
The source suggests an alternative. What if that lifespan extension is actually caused by the asymmetry of information flow?
Information flow, break that down.
Think about it. If a particle is moving near the speed of light, it is running into information from the front faster than information can catch it from behind.
Like running into the rain again. You get wetter faster on your chest than your back.
Exactly. The source asks, what if time itself is just the rate at which the universe feeds us information? If you change your speed, you change the rate of information flow, you change the metabolism of your reality, it's not that time warped. It's that the feed of data changed.
That is something I'm going to be thinking about for a long time. The idea that time is just data consumption.
It's a fascinating perspective. Whether you end up agreeing with Chat or sticking with Einstein, it forces you to look at the now differently.
It certainly does. We aren't just looking at a room, we're looking at a tapestry of delayed signals, a unit circle of history.
And we are the historians trying to make sense of it all.
I love that image. Well, that is all the time we have for this deep dive. A huge thank you to the Mysterious Zionod Chat for these mind-bending sources.
It was a pleasure to explore the impossible.
And thank you for listening. Keep asking questions, keep looking at the stars and the shoes on your feet and wondering, when is that actually happening?
Until next time.
See you in the future. Or maybe the past.